Welcome to Lab M1. In this week's lab, we'll discuss error and motion. To begin with, we'll answer the question, what is measurement? Measurement is an estimate of the measured quantity. We use the term estimate because measurement is prone to errors. What is error? It is the difference between the observed value and the true value. Errors are always present, even with the best of instruments. Error in a measurement can be divided into two parts, random errors and systematic errors. Random errors are unpredictable, they are due to random fluctuations and are statistical in nature. Random errors cannot be avoided and they are equally likely in both the directions. Systematic error, which is also called bias, is either due to equipment fault or experimenter's fault. An example can be an uncalibrated weighing scale, which will never give us the true value. To get a better understanding, we can plot a histogram of our data where we already know the true mean. In this case, the systematic error is the difference between the true mean and the mean of the measurements, and random error can be thought of as the spread of the measurements. Now the question arises, how can we minimize the effect of these errors? We can reduce random error by taking more number of measurements. This has the effect of averaging out random errors. We can also reduce random error by using more precise equipments. Now we'll move on to the demonstration of the laboratory equipment. The device that we have here is called a photogate. This device emits a narrow infrared beam in the gap, and when the beam is interrupted, the red LED lights up. Remember to insert the lead into channel number 1 of the interface. Now that the photogate is on and connected, we can move on to create an experiment using Data Studio. Click on the Data Studio icon on the taskbar to launch the Data Studio and select Create an Experiment. After that, choose channel 1 and set the sensor type to photogate and pendulum. Click on the Start button to start recording the data. After you have stopped recording, the data will appear as runs on the left side of the screen. You can then plot graphs using Data Studio. Click on the graphs and select the run that you want to be displayed, and the graphs will pop right up. You can similarly get histograms and data tables from Data Studio. For the second part of the experiment, you'll be using another instrument called the motion sensor. You can adjust the beam width of the motion sensor by selecting either the narrow setting or the wide setting. Connect the yellow and the black ends to channel 1 and 2 of the interface. Once the motion sensor is on and connected, you can hear the sound pulses being emitted by the motion sensor. These pulses, when reflected from an object, are recorded by the motion sensor, which then determines its position, distance, and speed. The same technique is used by whales, dolphins, and bats to locate their prey. Once again, open up Data Studio and create a new experiment. This time, select your instrument as motion sensor. Take different kinds of runs that are described in the lab manual. You can once again generate graphs, histograms, and data tables for position, velocity, and acceleration. Once you have collected your data, you can export it to a text file which can then be copied to other data analysis softwares such as Excel.